let's consider what's happening inside a large star. There are two fusion processes you need to know in detail: the PP chain, the proton-proton chain, and the CNO cycle. So it has to be a large star, something like 4 times the mass of our star, and it has to be hot enough in the core. So the CNO cycle. It's a cycle you could start anywhere, but I like to start with carbon. Nice, stable carbon-12. And then it's going to go around kind of a hexagon, like that, from stage to stage. So at each stage we can think what's most likely to happen, sort of work it out. Some of it's reasonably intuitive, some of it isn't. So carbon-12 is very stable, it's not going to decay. Every stage is a decay or a particle joins it. So it's going to get hit by something. The most likely thing to get hit by is still a proton. So if it does, think what it becomes. Well, that would become a 7, that would become a 13. So it's N. So CNO cycle. It does start with CN. So that's kind of nice. Now think about that. That's not as stable. Nitrogen 14 is stable, carbon 12 is stable, nitrogen 13 not stable. So it's going to decay, make itself more stable. Let's remind ourselves it's really got too many protons for the neutrons. So it's likely to change a proton to a neutron. From topic 7, a proton becomes a neutron, must also become, I'm going to write it as E plus here, but of course I could write it as beta plus, and of course it must make a neutrino. So on its way to the next stage, it's going to beta plus decay and produce that. So think what it becomes there. If it swaps a proton to a neutron, then the mass can't change, but the proton number must go down by 1. So it's 6, 13, so it's carbon. Not particularly stable either, but not that unstable. So what's likely to happen? Well, most common thing that's going to happen, think of the 6 stages around here. Most of them involve a proton. A proton joins, it comes along here, so that must increase to 7, that must increase to 14, which means we're back to nitrogen. So it's gained 2 protons along the way. One of them it changed into a neutron, so it's gained 1 of each. So what's most likely to happen here? Well, it's reasonably stable. It's quite stable, actually, nitrogen 14. So it's likely to be joined again by a proton. So think what it becomes. Well, this must be an 8. This must be a 15, which now makes it oxygen. So at least this bit here spells out CNO. So that's quite nice. Now, oxygen 16 is stable. Now it's kind of got too many protons for its number of neutrons again, so the same thing's going to happen. It's going to change a proton to a neutron. Think what it then becomes. So its mass doesn't change. Proton to a neutron, its proton number drops down to 7, and now it's nitrogen again. Along the way, it spat out, just like before, a beta plus particle and a neutrino. We'll summarize all this at the end. So now it's only got this one step left. How is it going to get along there? Well, we're on to nitrogen 7. What's the most likely thing to happen? It's going to be joined by a proton again. Now that would make it 8, 16, which would make it oxygen, which is stable, and yet with all that energy flying around, it could just decay. It could just emit helium. Helium-2, because this is a fusion process. We do keep pumping in protons, we get helium at the end. So then it would be back here. So it's gained a proton, but then it lost 2 protons and 2 neutrons, which would make it carbon 12. So let's summarize this. What did we put in? Well, we put in 4 protons. So of those 6 stages, 4 of them are just adding a proton. 2 of them are beta decay. One of them is also, so not just adding a proton, one of them is also spitting out helium. So we've made helium. and we've made 2 beta particles, and we've made 2 neutrinos, which as a net process is the same as the proton-proton chain. So it's catalyzed in that this main isotope, change between CN and O, isn't used up in the whole thing. It just goes back to where it was. So think of it kind of as a hexagon. It is CNO, but 3 of the stages are N. So it's like CN, CN, ON. CNO cycle there.